Even if the lithium-ion battery has established itself today as the preferred choice for the electric car, there are nonetheless alternative technologies available in today's market. Some are very old, such as lead-acid batteries, and some are new, such as lithium-ion batteries. We see various commercially successful EV models today, be it sport or economical models. The battery pack design is closely related to the performance of an EV, so keep watching till the end, because today, in this video, we compare different battery technologies used in the automotive industry. French physicist Gaston Planté invented the rechargeable lead battery in 1859, a technology used to store energy through electrochemical processes. Since then, it has made great progress. All the scientific work has had a similar goal: to find the best possible compromise between the battery's weight, storage capacity, production costs, lifespan, recharging capacity, and environmental impact, especially when the time comes for it to be recycled. The different types of electric batteries are: lithium-ion battery, hybrid nickel-metal battery, lead-acid battery, solid-state battery, nickel-cadmium battery, and nickel-metal hydride battery. The types of electric car batteries depend on the car system. The most popular electric car battery used is lithium-ion. The most suitable battery for hybrid electric cars is hybrid nickel-metal battery. Before going into these batteries in details, first let's understand how a regular battery works. So we all know how batteries are used in almost all the appliances we use in our daily lives and vehicles. Energy is converted to electricity, with the chemical energy stored in a battery. The battery consists of a negative electrode cell, which has a surplus of electrons that are negatively charged subatomic particles. Electrons flow from the negative to the positive when an electrical cable connects the two. Companies today have come up with a way to use the energy created by these moving electrons to run a motor. Since the vehicle's engine is powered by it, it must deliver enough current to the motor over some time. Well, does this battery expire? Unfortunately, the battery has an expire date after a few years. The battery dies when there is no electric flow between the electrodes. Usually, when the number of electrons on the positive and negative sides is the same, there is no current flow. At this particular period, the battery expires, and one has to replace it with another battery. Lithium-ion battery. The lithium-ion battery was most widely used electric car battery, and it is developed in the early 90s, and gradually established itself as the leading technology in transportation and the consumer electronics industry. You might already be familiar with it, because smaller versions of this are used in portable devices, like mobile phones, and even laptops. However, the ones used in cars are much bigger and have a higher capacity, often referred to as traction battery packs. Lithium-ion batteries have an immensely high power-to-weight ratio, making the vehicles more energy efficient. The battery performs relatively better than others at high temperatures as well. This is mainly used due to its energy per weight ratio, an essential consideration in electric car batteries. Lithium-ion batteries have higher energy densities than lead-acid batteries or nickel-metal hydride batteries. So it is possible to make the battery size smaller than others while retaining the same storage capacity. In other words, the smaller the weight of the battery, the further the car can drive on a single charge. The battery also has a low self-discharge level, meaning it is better able to maintain its charge when compared to the other alternatives. In addition to that, most components of the lithium-ion batteries can get recycled. This is a bonus for electric cars since they are made with the main motive of saving the environment. These are mainly used in plug-in hybrids and battery electric vehicles. Operation: a battery comprises an anode, cathode, separator, electrolyte, and two current collectors, positive and negative. The anode and cathode store the lithium. The electrolyte carries positively charged lithium ions from the anode to the cathode and vice versa through the separator. The movement of the lithium ions creates free electrons in the anode, which creates a charge at the positive current collector. The electrical current flows from the current collector through a device being powered by a cell phone or computer, etc., to the negative current collector.
The separator blocks the flow of electrons inside the battery.
The principle behind the lithium-ion battery is to circulate electrons by creating a difference in potential between two electrodes, one negative and the other positive, immersed in a conductive ionic liquid called the electrolyte. When the battery is powering a device, the electrons accumulated in the negative electrode are released via an external circuit to travel to the positive electrode. This is the discharging phase. Conversely, when the battery is charging, the energy supplied by the charger sends the electrons back from the positive electrode to the negative. The different battery types vary by ion types, electrode materials, and the associated electrolytes. The 12-volt lead-acid battery that has traditionally been used to power the starter of a combustion engine vehicle, for example, relies on an electrolyte containing lead ions and electrodes that are lead-based. The lithium-ion battery uses lithium ions, hence the name given to this technology. A lithium-ion battery, such as the one inside a car like the Renault Zoe, is designed as an assembly of individual battery units, or cells, connected and monitored by a dedicated electronic circuit. The number of cells, the size of each cell, and how they are arranged determine both the voltage delivered by the battery and its capacity. It means the amount of electricity it can store.
This is generally stated in watt-hours, or kilowatt-hours in the automotive industry.
There are various types of lithium batteries available. They are
lithium iron phosphate, lithium titanate, lithium nickel manganese cobalt, lithium manganese oxide, and lithium nickel cobalt aluminum oxide.
Advantages.
Lithium-ion batteries are getting better, as electric cars demonstrate.
Lightweight lithium-ion batteries were first used correctly in electric vehicles in the pioneering Tesla Roadster, manufactured from 2008 to 2012. It took roughly 3.5 hours to charge its 6,831 lithium-ion cells, which weighed 1/2 a ton, 1,100 pounds, and held 53 kilowatt-hours of energy. They were fully charged and gave the car a range of over 220 miles. Newer Teslas have far better cells and much greater range. A typical Tesla Model 3 has a 75 kilowatt-hours battery, half as much energy again as a Roadster, with just 4,416 cells, so they have much higher energy density and a range of 374 miles.
Disadvantages.
It is sensitive to high temperatures. If the battery is completely discharged, it can no longer be recharged.
It is relatively expensive. The nickel metal hydride battery. Another variant of electric cars is hybrid cars, which contain both battery-powered and fuel-powered engines. These cars mainly use hybrid nickel metal batteries, but these batteries are also compatible with battery electric vehicles. These kinds of batteries do not require any external power source to charge.
The charging of the battery mainly depends on the car's regenerative braking, speed, and wheels. When compared to lithium-ion batteries, nickel metal batteries have a better life cycle and are safer in case of intolerant use. However, these batteries have a higher self-discharge rate and are much more expensive, and generate considerable amounts of heat in high temperatures, which is common in a car. These few shortcomings make nickel metal batteries a lesser choice for a vehicle whose batteries need to be charged from an external source. This is also the main reason these batteries are used in hybrid cars.
With performance similar to nickel-cadmium technology, nickel metal hydride accumulators have seen more prolonged success due to their absence of heavy metals.
This portable rechargeable battery technology was the most economical at the beginning of the 2000s.
It largely dominated the hybrid vehicle market until the advent of lithium-ion technology.
Nickel metal hydride batteries, used routinely in computer and medical equipment, offer reasonable specific energy and specific power capabilities. Nickel metal hydride batteries have a much longer life cycle than lead-acid batteries and are safe and abuse-tolerant.
Advantages of nickel metal hydride battery.
Double energy density compared to lead-acid batteries.
Harmless to the environment. Easily recyclable. Safe operation at high voltage. It can store volumetric power and energy.
Cycle life is longer.
Operating temperature range is long. And it is resistant to overcharge and discharge. Disadvantages: reduced lifetime of around 200 to 300 cycles if discharged rapidly on high load currents, high self-discharge and heat generation at high temperatures, and reduced usable power because of memory effect. Lead-acid battery. Lead acid is one of the oldest kinds of rechargeable batteries. This battery is still found in many vehicles, those with both combustion and electric engines. In 1899, the electric car Vɪʀᴛᴜᴜ featuring this technology was the first automobile to exceed 100 km per hour, well before combustion engine vehicles. Compared to hybrid nickel metal or lithium batteries, these are a lot heavier and eventually lose capacity. However, automobile companies still use it mainly because of its cheap pricing. In addition, since they have been used for the longest time, the technology around the fitting and using the batteries more effectively has also evolved, making for a better end product. These days, lead-acid batteries are no longer used for traction but to power the electrical circuit of accessories or components specific to combustion engines, like the starter. The lead-acid batteries only offers a limited capacity despite its significant bulk and weight, but it is both inexpensive and easy to produce and recycle. Used as the primary energy storage mechanism for electric cars until the 80s, it quickly gave way to other more efficient technologies. Advantages of lead-acid battery. It is available in production volume, comparatively low in cost, and it was mature technology as used for over 50 years. Disadvantages: it cannot discharge more than 20% of its capacity. It has a limited life cycle if operated on a deep rate of state of charge. Low energy and power density. It is heavier, and it may need maintenance. Solid-state battery. Scientific research has long been exploring the concept of the solid-state battery. Still, it's only in the last 10 years that its progress has made it possible to envisage the technology's adoption by the automotive industry in the distant future. The principle behind it consists of replacing the battery's liquid electrolyte with a solid material that can take the form of a plastic polymer, compacted inorganic powders, or a mixture of the two. In theory, this technology is all positive. It makes it possible to increase energy density and stability, while making temperature control more manageable. Nonetheless, the solid state is still at the laboratory prototype stage, and the lithium-ion battery still has a lot of life left in it. Advantages of solid-state battery. These batteries are capable of delivering 2.5 times more energy density as compared to lithium-ion batteries. These are comparatively more durable and safe, less expensive and compact in nature. The recharge rate of solid-state batteries is 4 to 6 times more than regular ones. The greater electrochemical stability of these batteries make them more reliable. Disadvantages: the mass production and manufacturing of these batteries are quite complex. Research of solid-state batteries is still in progress, and the perfect material for the electrolyte, with an ideal ionic conductivity, is yet to be found. Nickel-cadmium battery. If you used rechargeable batteries in the 90s, you're already familiar with nickel-cadmium technology. Nickel-cadmium accumulators had plenty of advantages, with significant storage density and a lifespan of around 500 to 1000 charging cycles. However, they did suffer from the memory effect, a physical phenomenon that sees the battery's performance decline if it is subject to partial charge drain cycles. It is used for the production of electric vehicles in the 90s. Nickel-cadmium batteries are now prohibited due to the toxicity of cadmium. Advantages of nickel-cadmium battery. Long lifetime. It can discharge fully without being damaged, and it is easily recyclable. Disadvantages: cadmium can cause pollution in case of not being properly disposed, and it is costly for vehicular application. So what do you think about these batteries? Which are the best battery options for boosting EV performance? Let me know in the comments. Did you know that there are different types of electric vehicles, such as hybrids and fuel cells, that feature incredibly unique technologies and driving experiences?